just leave quietly. We have 3 bouquets, right? Oh, how beautiful. 1, 2, and 3. And what do we know about these lovely things? We know that they will be composed of 1 or more. So if it's 1 or more, this is grouping, right? And we have at least 1 in each group. So 1, 1, 1. Okay, great. Then it says of 5 kinds, L, P, R, S, T, L, P, R, S, T. Okay? Good. 1 and 3 cannot have any kind of flower in common. This is an unusual rule because it's like 2 groups can't share. So what I did is I said, okay, arc, cross it out. Whatever happens there can't happen there. By the way, what does that mean for the maximum number of flowers in groups 1 and 3? There are 5 flowers total. You could put at most how many in one of those groups?
4.
4. So you're either going to have 1 and 4, 2 and 3, 3 and 2, or 1 and 4, right? So you think about the 2 groups; they're capped by the number 5. Okay. Bouquets 2 and 3 must have exactly 2 kinds of flowers in common. Well, that means they each have at least two, and those things are equal. They're the same thing, right? Okay. 3 has snapdragons. That's a thing? Snapdragons?
Yeah.
Sweet. I wanted to put snapdragons in here, but why can't we technically do that?
Because then
You'll think it's in 2, right? It doesn't have to be in 2, at least as far as I can tell right now. So S goes there. Then it says if L then R. If L then R. This is significant. You have to write the rule with an arrow because it's not the same as LR. What's the difference?
If L.
If L then R. If you have R,
Then
you might not necessarily have L, right? So this is a one-way street. Anyways, then it says if you have L, then you can't have S. That one you can actually write as LS crossed out because if you have L, you can't have S, and if you have S, you can't have L. Right? Now, the last one, if T, then P. Okay, so if T, then P. All right. Are there any floaters? Doesn't look like it. 1, 2, 3, 4, 5. No. Okay. What inferences can we make on the basis of these rules? L cannot go in 3 because there is S here. I normally would write this above the diagram, but I ran out of space, so I'm writing it down there. Doesn't matter. What else? L, 1 and 3 cannot share anything in common.
So no S in 1.
No S in 1. Excellent. Okay. If you have L, then you have R, but if you don't have L, we have no idea. So R can certainly go in 3, right? Okie dokes. One thing to keep in mind, by the way, is that if you're ever debating whether to put T or P into a group, you have to put one of them, at least one of them. What do you know must be true?
It has to have P in it.
It has to have P, because if you have T, you're going to have P. So if you're debating between T or P, then you know that at least P has to be it. Because if T ends up going in, then P is going to come along. Same thing for L and R. If you're know that at least one of them has to be in the group, but you're not sure which one, you know R has to be in because if L goes in, R is going to come with it. Right? It's like baggage. Okay. So which questions are we going to talk about?
23.
23. Which one of the following cannot be true? Okay. Just no clues whatsoever. Just what can't happen. Let's start going through them. L and R are the only kinds of flowers in 1. L and R are the only kinds of flowers in 1. If L and R went here, right, and that was it, what could happen over here?
You have like P.
P, T, S, right? You have to have S.
Right.
I mean, if you have 2 here, you can't have any of those 2 over here, but we could have TPS and then probably put TP over there. It seems like it could work. So maybe we're missing something, but in the interest of time, TP are the only kinds of flowers in 1. So if TP goes here, then we can't have TP over here, which means we'd have to have what? Would we have to have?
No. R and
We'd have to have S, but I mean we can't have L, right? We can't have L in 3, so we'd have to have S and R. Does that work? Put TP here, SR, SR,
could have as well for 2.
and then you could put L in 2 if you wanted to.
That's fine.
Does every color have to go, or flower?
I don't think so.
It says each bouquet is to be composed of one or more of the 5 kinds, but it never says you have to have all 5 kinds. So we could have L here, but we don't even have to. So this seems fine. Okay. C, L, P, and R are the only kinds of flowers in bouquet 2. Okay, so if we have L, P, R, oh, wait. No? Okay, let's say L, P, R are all right here.
That's fine. 'Cause you could just have PR in 3 and that would match the 2.
Okay, so L, P, R, we put the P, R here, and the S, right? What's gonna happen then?
You're going to have in 1, it'll be pretty limited. You'll have to have P in it, I think.
Okay, so if we have, wait, hold on. Sorry, I already forgot who's in here.
LPR in 2 and then S in 3, right?
Yeah, so this is L, this would have to be PR, right? And then PR would have to go over here, which does not trigger T, because that's the opposite. Now over here, we could not have S, we could not have P, we could not have R, so what would we have to have?
Just T alone, but it cannot go there.
Wait, we could just have what?
We can have T, but it cannot go there.
Why can't T go there?
Because then it triggers P.
T would trigger P, which would conflict with that, right? So could you put L here though? That would trigger R, which would conflict with that. So over here, right? So if you bring L in, then you're going to conflict with that R. If you bring T in, then you're going to conflict with that P. So there's no options. That's a tough question. You have to kind of
Next time.
go all through it, right? But
Okay.
bottom line is if this is what you have, then you have to have PR, like you said, which leads to either L or T, which is not good.
Can I do 21?
21, no problem. Okay, 21. If T is in 1, which of the following could be a complete and accurate list of the kinds in 2? Okay, so 21, let's get rid of this actually. 21. So if T is in 1, right? What do we know must be true?
And P is in 1.
Yep, P's got to go here. Okay, so if we know that about 1, what else do we know?
The T and P cannot be in 3.
T and P cannot be in 3. Do we know who is in 3?
S.
S?
R.
R. Why S and R?
Well, Snapdragons has to be in 3.
Yes, S has to be there.
And R, because it's not in 1, and R won't trigger L. And L can't be in.
L can't be there. Really, there's nobody left, right? The only things left are S and R. Because if you can't have T and P, you only have 5. So T and P are gone. L's gone because L can never be in 3. So we only have 2 left, and you have to have at least 2. So it's got to be S and R. So S and R come here. And if those are the only 2 in 3, then they have to go into 2.
Okay. I think I was confused about if all the flowers had to go in, so I thought L had to be in. And other questions, like none of the answers had L in, so that's what confused me.
Yes. Yeah, in this case, if T and P are the only things... Well, no, it just says if T is in 1. If T is in 1, which one? Yeah. Yeah, we can't put L anywhere in this game.
So you don't, so yeah, I thought we could put all the flowers, I was like, wait a minute, doesn't, L can't fit. Okay.
Yeah.
That makes sense.
Okay. So which of the following completely accurate? Oh yeah, so we're looking for something that has S and R. The only thing that has S and R is E. Is it okay to bring in T and P?
Yeah.
Yeah, because we have to have exactly 2 in common. We could have T and P here, but that's okay because it's only 1 and 3 that can't be the same.
Yeah.
2 can be the same as 1, so it's not a problem, or at least overlap. All right, any other questions on this one? Okay.